Thank you for joining me here on Twitter Think channel. In today's video, we are doing the third example under second order differential equation. That is why I have labeled it part 3. There is a previous video under this topic named the solution type of second order differential equations. You need to watch that one. It will help you to understand how to generate the solutions for a different type of differential equation that you come across depending on the auxiliary equation. I mean the roots of the auxiliary equation. So in this question, we have 3d squared y over dx squared plus 2dy dx plus y equal to this function. And we are saying they are asking us that show that the general solution of this function is what we have here. So we have y equals exponential function, exponent of negative 1 over 3, a cos root of 2 over 3x plus this equal to that. This means that you need to solve this second order differential equation to generate the solution we have here. So by the end of the day, if you finish solving this one, you will get this result. So how do we tackle this question? The first thing we should know from our solution type video is that we need to pick the left hand side of the equation and equate it to 0. This is called the complementary function of the equation. We need to solve it, and then we come to the particular integral function, which is on our right hand side. We will solve that one too. When we finish, we generate the general equation by combining the complementary function and the particular function to generate the general solution. So what will be our complementary function? So this is how we go about it. Dy dx plus y. And to find the complementary function, this whole side should be equal to 0. So now we find the auxiliary equation. So we have 3m squared plus 2m. The coefficients of y is 1 plus 1 equal to 0. So this is a quadratic function. We need to solve this one to generate the root of m. Now, looking at this, the roots of this function are complex. You can check this using your calculator. So I need to factorize this using the quadratic equation. So from minus b plus or minus root of b squared minus 4ac all over 2a. We know a is equal to 3, b is equal to 2, and c equals 1. So I'll just substitute these values inside. So let me use m equals b is 2. So I have minus 2 plus or minus root of 2 squared minus 4, a is 3, and c is 1. All divided by 2a, where a is what? 3. So now when we work this out, we are getting m equals minus 2 plus or minus root of 4 minus this time this will give us 12 out of 6. So when we continue this, we are getting m equals minus 2 plus or minus root of minus 8 all out of 6. So now we change this to complex numbers, and we are having m equals minus 2 plus or minus root of 8 times root of minus 1. This time this will give you this. So we divide this result by 6. You must note that root of minus 1 is I. So the complex notation I. So m equals minus 2 plus or minus root of 8i all over 6. Let me continue this here. Now when you punch root of 8 on the calculator, you will get 2 root 2i. This will give you 2 root 2 all out of 6. I want to complete this on this sheet. So in our next, we have minus 2 out of 6 plus or minus 2 root 2i out of 6. This one can move here 1. We have 3. This one this into this 1. So therefore, our m equals negative 1 out of 3 plus or minus root of 2i all over 3. So therefore, m1 equals negative 1 out of 3 plus root of 2i all out of 3, and m2 equals the negative side, which is negative 1 out of 3 minus root of 2i all over 3. Now these are the roots m1 and m2. You can see that m1 is complex, m2 is also called. The functions or the root of m are all complex. Now if the root of m are complex such that we have the real term and the imaginary term, then what will be the general solution for y? We learned in the previous video that the solution type video, if you have finished watching, we learned that if the auxiliary equation generated a complex root where m is equal to a plus or minus ib, then we have m1 to be this, m2 to be this, as I have generated here. Then the general solution y, we proved that will be in the form y equals a or exponent of ax bracket a equals bs plus b sine or bs. Now all you need to do is that whatever value you have for a is negative 1 out of 3. Whatever value you have for b was 2 over 3. You just substitute it here. So you place b here and you place a here. And this general solution should be in your head. There is no need for you to prove what I have done. I have proven this in the solution types to tell you that the general solution for a root of this form for second order will be this. So our final answer becomes y equals e raised to the power negative 1 out of 3 into bracket a cos, and what is b? B is root 2 over 3, root 2 out of 3x plus b sine root 2 out of 3x, bracket close. Now the question was left, the solution was supposed to be in exponent exp, not e. E simply means exponent, so all you need to do is to change the e to exp. So let me rewrite the term again. Now y equals exp negative 1 out of 3 exponent this. Then I have a cos root 2 out of 3x plus b sine root 2 out of 3x. And this is our solution for the complementary function. Now we need to go back and work the solution for the particular integral type. This part is called the f of x function because it's the complementary function equals what? F of x. And f of x is x squared minus 2x plus 1. Now if f of x is of this form, then what will be the assumed particular integral? I'll take you back here. Watch this carefully. If f of x, which is the function, has the term kx squared, then you assume that y equals cx squared plus ds plus e. In this solution, I will not be using c, d, and e. I will be using m, n, and p. When you watch the solution types video, if the function contains kx, where k is the coefficient of x term, then y will be of this form. If the function f of x, that means if this side of the function was sine x or cos x, any of them, then k sine x or cos x will give you the assumed particular integral function as c cos x plus d sine x. So since we have an x squared term here, we assume that for particular integral, y is equal to ms squared plus mx plus p. Now in this solution, I assume that y is equal to cs squared plus d, but I was using m, n, and p, so I wasn't using c, d, and e, so it's still the same thing. Now, I will label this one equation 1. Then, I'll go back to the function because the original function given to us has a second derivative and a first derivative here. So we need to differentiate equation 1 2 times. So I'll differentiate this one. Dy dx will give me, when we differentiate this, we are getting 2mx plus, when I differentiate nx, I'll get what? N. The 1 here times n, 1 minus 1 will make x raised to the power 0. Anything to power 0 is 1. Now, p is a constant, which we don't yet know. So when we differentiate a constant, is 0. So I'll name this side equation 2. Now, I'll differentiate the equation 2 the second time to get d square y ds squared will give me, when I differentiate this side, I'll get 2m, and then x will go away. When I differentiate n, which n is a constant, it will give me 0. So this is equation 3. We will go back and rewrite or substitute this result into our original function. So now we have equation 1, equation 2, and equation 3. Now we rewrite our main function given to us. This is our main function. I have labeled it equation star. So you substitute equation 1, 2, and 3 into equation star. So now, how do we do that? All I need to do is that d square y ds square is this, which is 2m. dy dx is 2mx plus n. I'll put it here. And y equals mx squared plus nx plus p. I'll substitute it here and equate it to s squared minus 2s plus 1. Then I can expand and solve for m, n, and p. So let's do that. So we have 3 into 2m plus 2 into 2mx plus n plus y. And y is this. So we have mx squared plus nx plus p equal to x squared minus 2x plus 1 coming from here. We have substituted everything inside. Now I can expand. This will give me 6m plus 4mx plus 2n plus mx squared plus nx plus p equal to x squared minus 2x plus 1. So we group like terms and then we can solve. So I'll first write this side mx squared, then I write the x term. So the x term we have plus 4mx plus nx. Then I'll write all term that has a constant. So plus 6m plus, we are left with this side, 2n plus p equal to x squared minus 2x plus 1. So I can factorize x here. So this will give me mx squared plus 4m plus n in one bracket, then I factorize the x out, plus let me put all this side in brackets since it is going to represent the constant, plus 6m plus 2n plus p equal to x squared minus 2x plus 1. So now this has become simple. We can now compare all x squared term with the right hand side x squared term. We can compare all term for x with this side, and we can compare all constants with this side. So now we compare the coefficients on the left side and the right side, like I've already said. So we have m equals 1. Why? Because m here, mx squared, 1x squared. So therefore m equals what? 1. Then we compare the x term. So we have x here, x here. So therefore 4m plus n equals, what is the coefficients of x here? Minus 2. Because minus 2. So now we can work for n, since we know m to be equal to 1. So we can have 4 into 1 plus n equals minus 2. So 4 plus n equals minus 2. N equals minus 2 minus 4. So therefore n equals minus 6. Now if n equals minus 6, then we can find p. So we now compare all this side with the constant. So everything here equals what? 1. So we have 6m plus 2n plus p equals 1. So we know m to be 1, n to be 6. So we have 6 into 1 plus 2 into minus 6 plus p equals 1. So we have 6 minus 12 plus p equals 1. So p equals, I'll carry everything here to this side. This and this will give me minus 6. So p equals 1 plus what? 6. This side is minus 6. When I carry it here, I'll get plus 6. So p equals 7. So therefore, I can rewrite this by saying m equals 1, n equals minus 6, and p equals what? 7. So these are the values that we will use to replace equation what? Y, because this is what we are interested in. We are interested in y equals mx squared plus nx plus p. So we substitute the values of m, n, and p into equation 1 to generate the particular integral function. So we have y equals x squared, m is already 1, so 1x squared minus 6x plus 7, and this is the solution for our p integral. So p integral function equals is y equals x squared minus 6x plus 7. Now you need to rewrite your general solution for the function or the question given to you. You write our general solution. General solution is the complementary function solution plus the particular integral solution. So we say that you write that y general equals CF plus PI. So what is our CF? We have already calculated the CF function to be this. So I'll write it. My y general equals exponential function -1 out of 3 a cos root of 2 over 3x plus b sine root 2 over 3x, then plus our p function is what we have here, x squared minus 6x plus 7. So this is our final solution. So now when we compare the solution that we have generated, we were asked to solve the differential equation this to generate this, and this is our solution. As we compare, we have generated the same solution, which is what we have here. So this is how you solve second order differential equation of this form. If this video was helpful, subscribe to my channel. My name is Daniel. I'll see you in my next video.